right. Part 3, and then they'll be done. So part 3, when multiplying two fractions such as 3/8 times 2/5, there are two ways you can use to write the product in simplest form. You can so method 1 would be simplify after multiplying. So this is what we've been doing. You go ahead and multiply across. So 3 times 2 is 6, 8 times 5, 8 times 5, 8 times 5 is 40. And then when we get our final answer, we can simplify that down. So 6 over 40, what can I pull out of a 6 and a 40? Well, I can pull a 2 out of there. So 6 divided by 2 is 3. 40 divided by 2 is 20. Is there anything I can pull out of a 3 and a 20 with no remainder? Well, no. So that is my product in simplest form. All right. Notice the tie-in. If you want to go directly from a number to its simplest form, you divide the answer by the greatest common factor, the GCF. If you don't use the GCF, you'll get an answer, but it will not be in simplest form. So like, let's say, remember the 4/8 example, the 4/8 down to 1/2. I did not simplify by the greatest common factor, right? I divided by 2 and then I divided by 2 again. So let's look at a different example. Let's say I do 8/16. What is the greatest common factor between 8 and 16? Well, they both share 1, they both share 2, they both share a 4, they both share an 8. Is there anything bigger than an 8 that I can pull out of an 8 and 16? Well, no, so 8 is the greatest common factor. So if I divide 8 by 8, I get 1. 16 divided by 8 is 2, so I get 1/2. All right, so you could do 8 over 16. You can pull a 2 out of it and get a 4 over 8, and then you can say, okay, what can I pull out of a 4 and an 8? I can pull a 2 out of both of them, so 2 over 4. What can I pull out of a 2 out of a 4? Well, I get 1. I can pull a 2 out of both, so 2 divided by 2 is 1, 4 divided by 2 is 2, and you get to the same final answer. It's just more steps, and you're more likely to make a mistake. So if you use the greatest common factor, there's only one step, you're less likely to make a mistake. All right. Method 2 would be to simplify before multiplying. Method 1 is simplify after. Method 2 is simplify before. So how would you do that? Well, you can divide the numerator and the denominator by either factor by their greatest common factor. Divide 8 and 2 by 2. Okay. So what you're looking at is the denominator of one and the numerator of the other, and you say, what can I pull out of both of these? Well, I can pull a 2 out of 2, and I can pull a 2 out of 8. So a 2 divided by 2 is 1. 8 divided by 2 is 4. So this would change from 3 over 8 to 3 over 4 times, instead of 2 over 5, 1 over 5. All right. So once we have the simplified factors, 3/4 times 1/5. Now we just multiply. Do 3 times 1, numerator times numerator, over 4 times 5, denominator times denominator. 3 times 1 is 3, 4 times 5 is 20. Notice you get the same answer no matter if you simplify before method 2 or after method 1. They always get you the same place. It's just whether or not you simplify before or after. Okay? I would suggest for right now picking the method that you feel more comfortable with. They get you the same place, they're the same amount of work, pick the one that you feel more comfortable with. If you're someone who already can do method 1 with 100% accuracy, challenge yourself. See if you can do method 2. The biggest mistake I'm going to see here is you're looking for a numerator-denominator pair. Okay, so 2 and 8. Okay, let's look at a different one really quick. Let's say you did... So let's say you did 9 over 12 times 3 over 6. So I'm going to quickly make my numerators not yellow, red. So numerator is 9, numerator is 3, denominator is 12. We'll make those blue. Denominator is 6. Okay, so 9 over 12 times 3 over 6. Well, what can you pull out of a 9 and one of the two denominators? So let's do the 9 and the 12. What can you pull out of a 9 and a 12? Well, you can pull a 3 out of both of them. So if I do pull a 3 out of 9, 9 divided by 3 is 3. 12 divided by 3 is 4. So I can simplify 9/12 as 3/4. All right, times Now 3 and 6, we can pull out the 3 and the 6, we can pull a 3 out of both of them. So you get 1 over 2. Okay, so 9/12 times 3/6 is the same thing as 3/4 times 1/2. So notice that I pulled a 3 in both of these examples from the same pair, right? I pulled, here's one pair, I'll highlight it with that background, and I'll highlight this guy with that background. I pulled a 3 out of the numerator and denominator from the same pair. Now let's see what happens if you pull a numerator and denominator, or you pull a copy from the opposite fraction. So what do I mean when I say that? Let's get rid of everything. So the 9 here and the 6 here. So I'm going to highlight both of those. Let's use green, so a different color. What can I pull out of a 9 and a 6? Well, 9 and 6, you can pull a 3 out of both of them. So 9 divided by 3 is 3. Now I'm going to leave a blank space here because we haven't touched the denominator yet. Well, here, let's go ahead and put a 12 because I haven't touched the denominator. Times 3, so 9, I pulled a 3 out to give me 3, haven't touched that denominator, leave it alone. 3 I haven't touched, leave it alone. 6, if I pull out a 3, you get 2. So now I touch the numerator here and the denominator from here. So I'll unhighlight all of that. So what do you get now? Well, I still have this denominator. We'll highlight, let's say yellow, and this numerator. All right. What can you pull out of a 3 and a 12? Well, I'm going to leave the same numerator. I am not touching that. 12 and 3, denominator of the left, numerator of the right. What can you pull out of both of them? Well, you can pull a 3 out of both of them. 12 divided by 3 is 4 times, now what can you pull out? We said we pulled a 3 out of the 12, so 3 out of a 3, 1. Haven't touched this 2, so the same denominator. 3/4 times 1/2, look, same exact thing that we got if we simplified the same from numbers from the same pair. So if I simplify from the 9 and the 12 first, I get 3/4 over 1/2. And then if I simplify from the numerator from the left and the denominator from the right, you still end up with 3/4 times 1/2. So what does this mean? That means you can simplify either from the opposite pair, so denominator, numerator, so you can do it diagonally, or you can do it from the same pair, okay? So you have options. In your companion book, you have this.
How far is this library, man? My dogs are barking. Don't even start with me. We're almost there.
All right, find the area in square miles of a rectangular city neighborhood shown in the diagram below. So it has a length of 1/3, or excuse me, a width of 1/3, a length of 9/8. So how will you find area of a square? Well, area of a square equals length times width. So what's my length and my width? Well, it has a length of 9/10, so a width of 1/3. So area equals 9 over 10 times, excuse me, 1 over 3. So 1 over 3. So area equals, we already know how to multiply fractions, so we have options here. We could either simplify before, we could say, okay, well, numerator, denominator, 9 and 3, what was it shared? Shares of 3, I could simplify like that. I personally like to solve it and then simplify. So let's do that. 9 times 1, numerator times numerator is 9. Denominator times denominator times denominator, 10 times 3 is 30. So I get 9 over 30. And what can you pull out of a 9 and a 30? Well, I can pull 3 out of both of them. So we're going to divide by 3 in the numerator and the denominator. 9 divided by 3 is 3. 30 divided by 3 is 10. So 3 over 10. So the area of this guy is 3/10 of a mile. 3/10 square miles, excuse me. So this is the example I just did. We multiply, we get 9 over 30, then we pull a 3 out of the numerator and the denominator, we get 3 over 10. If you simplify before multiplying, so 9/10 times 1/3, you pull a 3 out of the 9, a 3 out of the opposite denominator, you get 3 times 1 is 3, 10 times 1 is 10, which is 10 over 3. So method 2 can sometimes be shorter in the amount of work depending how the numbers work out. I just feel more comfortable with method one. So I like method one, that's how I do it. There are certain times when method two is more beneficial. So pick and choose depending on the scenario. All right. In your companion book, you have this. Find the area of the piece of grass sod modeled in the diagram. Write your answer in simplest form. So you have 5/6 as your length and 3/5 as your height of your width. Go ahead and solve for the area. And a reminder, area is length times width. So pause the video, take 2 minutes, try this out. All right, here are our answer choices. Correct answer, 1/2 meter square. And why is that? Well, you're going to multiply length times width, so 3/5 times 5/6. So I like method one, 3 times 5, 3 times 5, 5 times 6, 5 times 6, numerator over denominator. 3 times 5 is 15, 5 times 6 is 30. Now I get 15 over 30. What can you pull out of a 15 and a 30? Well, the greatest common factor is 15. You could also do 5s and say, pull a 5 out, get a 3 over 6, and then simplify that. We can pull out a 3 and a 6. Well, you can pull a 3 out of the numerator and 3 out of the denominator, so 1/2. But let's use greatest common factor. What's the biggest number you can pull out of 15 and 30? Well, you can pull a 15 out of both of them. So 15 divided by 15 is 1. 30 divided by 15 is 2. So the area is 1/2. Method 2, exact same thing. 3/5 times 5/6, but now we're going to simplify. So 3 and 6, what can you pull out of that? Well, you can pull a 3 out, so 3 divided by 3 is 1, 6 divided by 3 is 2, and then you have 5 and 5. What's the biggest number you can pull out of both 5 and 5? Well, you can pull a 5 out of 5, and you can pull a 5 out of the other 5, so you can divide both of them by 5. 5 divided by 5 is 1, 5 divided by 5 is 1, so you get 1 times 1 is 1, 1 times 2 is 2, so it just goes 1/2, okay? Once again, pick and choose your methods. There's no right or wrong one, they're just different. All right, and that concludes 5-2. Go ahead, flip the page. You're going to do the close and check. I'm gonna give you, let's say, 8 minutes, and then I'll put the answers up on the board and you'll correct. So pause the video, take your 8 minutes. All right, let's start with our focus question. Is the product of two proper fractions greater than the fractions being multiplied? No, the product will be less than both fractions if the fractions are proper fractions. So an example would be 1/2 times 1/3 equals 1/6. 1/6 is less than 1/2 or 1/3. Again, it's that pie. If you have a slice of pie and you divide that slice into more slices, you'll never get more pie than that original slice. You're always finding a part of a part, so it's always getting smaller. All right, question number 1, use the unit square to show 3/4 of 1/3. So 3/4, well, 1, 2, 3, 4, we're going to divide vertically into 4 groups. 1/3, denominator is 3, so 1, 2, 3 groups going left and right. You could have also flipped it, and that would have been, I can't do this, but if you take the square and rotate it 90 degrees, so vertically it has 3 groups and horizontally it has 4 groups, you would get the same answer. 3/4 are shaded in, so these are shaded in. And then, because it's 1, 2, 3 rows out of the 4 total rows, and then 1/3, 1, 2, 3, you're going to shade in one of those, and you're looking for the intersection. Well, it's these 3 overlapping. So how many are shaded in? 3 out of 12. So 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how'd they get 1/4? Well, you have to simplify 3 over 12 to get 1/4. All right. Find the product of 7 over 12 times 4 over 5. Write the product in simplest form. Well, 7 times 4, 28. 12 times 5 is 60. 28 over 60, you can simplify to 7 over 15. Find the area of the postage stamp in simplest form. Again, area of a rectangle is length times width. So 5/9 times 10/3. 5 times 3, numerator times numerator, is 15. 9 times 10 is 90, so you have 90 over 15. Why does it say 1/6? Because you have to simplify 15 over 90. All right. Number 4, how's the product of a proper fraction and whole number similar to and different from the product of two proper fractions? Well, in both cases, the product is less than the greater of the two factors, so it's always smaller, the product of a proper fraction and a whole number is equal to or greater than the original fraction, but less than the